So before we continue our section on solving quadratics, first we need to talk about how to simplify and rationalize some square roots. So in case anybody doesn't remember or doesn't know what a square root is, let's just talk about it. So let's consider 3 squared equals 9, right? That's true. 3 times 3 is 9, so 3 squared would be 9. Well, if you notice, another way that we could write that would be that 3 is the square root of 9, right? So basically what this means is that if we have b squared equals a, we can see that b would be the square root of a, right? Where that symbol is called the square root sign. So this number underneath the square root sign, that a, we call that to be the radicand. And this together, this whole thing, right, the square root and the radicand, we call just the square root expression. So let's talk about simplifying these. So this is the way to simplify. So first, we need to break up the radicand into a product of two factors. Then we break up each of those factors into a product of two more factors. We can continue this until we only end up with prime numbers. Remember, prime numbers means that the only factors are going to be 1 and itself, are the only factors. So ultimately what this is called the prime factorization, in case anybody was curious. All right, so let's go ahead and let's do an example as we do this, right? So we can have 64. All right, so we can break up 64 into the product of 2 and 32, right? Can't break up 2 anymore, right? Because that's just 2 and 1, but we can break up 32, right? That's going to be 2 and 16, right? We can break up 16 into 2 and 8. We can break up 8 into 4 and 2, and we can break up 4 into 2 and 2, right? So, remember this is a product, so we're multiplying, so the square root of 24 is the same as the square root of 2 times 2 times 2 times 2 times 2 times 2. So we have 1, 2, 3, 4, 5, 6 2's. All right, so let's look at number 2. So number 2, we need to circle pairs of numbers. For every pair, one number will come outside of the square root. So circle the pairs of numbers. For every pair, one number will come outside. So here's a pair of 2's. Here's another pair of 2's. Here's another pair of 2's, right? So for this pair, 1, 2 will come outside. For this pair, 1, 2 will come outside. And for this pair, 1, 2 will come outside. All right. Step 3 is we multiply all the numbers outside the square root. Number 4, we multiply all the numbers that are left inside the square root. And then lastly, step 5, we just place those two numbers together as one term. Where step 4, of course, will be under the square root. So in this case, there was nothing left inside the square root, so the square root goes away. We're going to multiply these, and what we see is the answer is 8. So the square root of 64 is 8, which, yeah, of course it is. Good. All right, let's look at another example. So the square root of 75. So 75 can be broken up into into 3 and 25. That's the way I wanted to do it. And that can be broken up into 5 and 5. So step 2, circle the pairs. So we see that we have a pair of 5's. So that means 1 5 is going to come outside. So we have a 5 on the outside. There's no other pairs. So then what's left inside is the square root of 3, right? That's the only one left inside. And so that's what we get when we simplify the square root of 75. All right, let's do square root of 54. So we can break this up into 9 and 6. We can break the 9 into 3 and 3. We can break up the 6 into 2 and 3. So we circle all the pairs. So here's a pair of 3s. So that means 1 3 comes out. There's no other pairs left, right? So we see this is going to be 3 times the square root of 2 times 3, because remember it's a product. So the final answer is going to be 3 square root of 6. All right, let's look at one more. So if we have the square root of 480, so we can split that up into 48 and 10. We can split up the 10 into 2 and 5. Can't split these up anymore, right? So we can split up the 48 into 4 and 12. We can split up the 12 into 4 and 3, the 4 into 2 and 2. We can separate that 4 into 2 and 2. So we have a pair of 2's, so 1 2 comes out. We have a pair of 2's, so 1 2 comes out, since we're multiplying those two, right? So notice the end numbers are going to be 3, 2, and 5, right? We're going to look at the ends of all of these numbers. So on the outside, we get 2 times 2. And on the inside, we get 2 times 3 times 5. Which means if we multiply these together, right, we get 4 times the square root. 2 times 3 is 6. 6 times 5 is 30. 4 square root of 30. All right, let's look at dividing radicals. So if you have the square root of a over b, that's actually the same as the square root of a over the square root of b. So it's kind of like the radicals, or the exponent rule, right? Good. And so from here, this is how we can split it up, and then we can decide, simplify it from there. So for instance, let's simplify these. So we can see that this is going to be the same as the square root of 4 over the square root of 49, right? Square root of 4. We know it can be 2 and 2, so that's just 2. Square root of 49, that goes down to 7 and 7, so there's that pair. So over 7. So our answer is 2 over 7. All right, let's look at this one. So we see that we get the square root of 100 over the square root of 9. So the square root of 100 and the square root of 9. 9 obviously simplifies to 3 and 3, so 3 comes out. 100, we got 10 and 10. Now if you notice, we can keep going, which if you want to, you absolutely can, but we actually already have a pair, right? 10 and 10. So if we want, we can just stop a little sooner and just say that that's going to be a square root, right? Because we already have a pair, so we can just take that 10 out. And then we're done. There's nothing left in there. But if you want to keep going, you absolutely can as well. Whatever works for you. All right. So let's do the next one. So we see this is the square root of 32 over the square root of 25. So square root of 32, we get 8 and 4. We get 4 and 2, 2 and 2, and 2 and 2. So we can see there's 1 2 that comes out. There's another 2 that comes out, and we're left with a 2 inside. All right? So we can see that that's going to be 2 times 2, which is 4, square root of 2. Now let's do square root of 25. We can break that down into 5 and 5. So that pair comes out. And our final answer is 4 square root of 2 over 5. All right. So last one, and then we'll do rationalizing, and then we're done. So we have the square root of 300 over the square root of 81. So split up 300. We get 3 and 100. We get 10 and 10. Again, we can just stop there because we already have a pair. There's no other pairs to be had, right? So that's going to be 10 square root of 3. And then we get square root of 81. You know, that's 9 and 9. So again, we can stop right there. Right? There's a pair. So the 9 comes out. So we get 10 square root of 3 over 9. All right. Last topic. And then we'll be done with this lesson. So when a denominator contains a square root, that's not great. So we need to make sure that denominators never contain square roots. So denominators cannot contain square roots. Right? So it's just something that we don't do in math. It's kind of like, again, if you wrote the sentence, I love math, I know what you mean, but it doesn't quite make any sense, right? You need that capital I if you're in English class, right? So kind of the same thing. It's just the way that we do math. We don't have radicals or square roots, excuse me, in the denominator. So a way to get rid of a square root in the denominator, you just multiply both the numerator and the denominator by that square root expression. So whatever was in the denominator, you just multiply that both by the top and the bottom. And then remember, when you're multiplying square roots, you can always combine to get under one square root sign. So let's take a look at this. So this is called rationalizing a denominator. So let's rationalize example number 3. So we have a square root in the denominator. We see it's square root of 6. So we just multiply by the square root of 6 over the square root of 6. When you multiply fractions, you multiply across. So we get the square root of 6 times 5, right? Because you can just put everything under one denominator over the square root of 6 times 6. Well, we can see that the square root of 6 times 6, we already have a pair, right? So we can take out that pair. We can take out that 6, and there's nothing left on the bottom. Now with the top, we have the square root of 5 times 6. You can multiply that out, or since we're going to have to separate them anyway, right, you can see that we get 2 and 3. Well, there's no pairs to be had here, so we've got to multiply all those together. So we end up with the square root of 30 over 6. That's the rationalized. So you still want to make sure to simplify always when you're doing anything with radicals. So you may end up having to simplify things a little later. All right, let's check out this one. So we have a square root of 7 on the bottom, so we multiply by the square root of 7 over the square root of 7. All right, so the top, we're going to get the square root of 21. There's no way to simplify that because that is just 3 and 7. Or I guess we can leave it like that. So 3 times 7 over the square root of 7 times 7, right? So on the bottom, we see that we do have that 7 pair, so we can take out a 7. On the top, 3 can't be simplified anymore, 7 can't be simplified anymore, so we just multiply it together. So we end up with the square root of 21 over 7, and that is simplified. All right, let's do another one. So we have the square root of 6 over square root of 8. So we're going to multiply by the square root of 8 over the square root of 8. So on the top, we get the square root of 6 times 8. On the bottom, we get the square root of 8 times 8. So on the bottom, again, we see that that 8 can come out. So we have an 8 on the bottom. Now let's look at the top. Now again, you can multiply it out, but since we're going to have to, the next step after you multiply it out is just to simplify it again. Let's just keep it simplified. All right, let's keep it as a product. So 6 can be taken down to 3 and 2. 8 is going to be 2 and 4. 4 is going to be 2 and 2, right? So circle the pairs because we need to simplify. So we see that there is a pair of 2's here, and there's a pair of 2's here. And we see the only thing left over is this 3. So on the top, we're going to end up with 2 times 2, which is 4, times the square root of 3. And we still need to make sure to simplify fractions too. So we see this 4 and this 8, right, can be simplified. 4 divided by 4 is 1. 8 divided by 4 is 2. So we see this is the square root of 3 over 2, because 1 times square root of 3 is the square root of 3. So that is the simplified radical. All right, last problem. So we got square root of 15 over square root of 3. So we can just multiply by the square root of 3 over the square root of 3. All right, so on the top, we get square root of 15 times 3. On the bottom, we get the square root of 3 times 3. So again, that bottom, 3 is going to come out. So no more radical. And on the top, we got the square root of 15 times 3. 15 can be separated into 3 times 5. So we do end up with a pair. So this 3 comes out, and we're left with 3 square root of 5. But of course, 3's can cancel, so we're really left with square root of 5. All right, and that's it. So again, this is it's just good to have kind of a foundation of this. We'll be using this later on when we're talking about quadratic equations and completing the square. But this is the end of this lesson. If you have any questions, of course, you can always let me know.